So you see here, rows affected 1, and that has to be bills, right? So ID equals to 2, and let's look at our database here. If we update and watch for bills address, it has been updated to 48 Range Road. Yeah. Okay, let's try another one. We can definitely copy and paste here. Where let's check and see name, okay, equals to Peter. Yeah, so we can then change the address to 7 Door Street. Okay. Okay, so if we do that, what happens? Let's run it. Rows affected 2, because remember this is resetting everything, right? So we update, and we now perform 2 updates here. Okay, so update correctly identified ID2 and updated it, regardless that original data was the same as the the new data. Actually, they hold the same address, right? However, it was actually overwritten, and so that counts as 1 row affected. And Peter now no longer lives in Wall Street but Door Street, and that has been updated as well. Okay, let's go back to our classroom slides. Okay, next we want to delete from the table. So delete is different from drop, remember? So we drop database for other SQL language, not for SQLite. We drop table, but we delete row. So from that perspective, it is nice because we won't accidentally drop table when we meant to drop certain rows. So the way it goes is drop from the table. Again, it's based on constraints, yeah, relationship and constraints. It's not it's not fixated on IDs only. So we can specify a whole bunch of constraints that the rows have to satisfy, and once they are satisfied, they are being extracted out. And of course, this operation is to delete them, remove them. So whenever we positively identify using the condition, those rows will be deleted. Okay. And we can also delete from table without any filtering. What that means is to clear out the entire table. Okay, so we can delete from customer where address like %O, capital O, %. Here is where I can introduce this new and really powerful syntax to select any kind of strings that contain capital O. So % means none or more characters of any sort before the O. So % here. Yeah. And % on the right means again any characters and whatever the length. So on the right of O. So delete from that. So we see that Kate has got a big O, Bill has got a big O, and in this case, Mary's address doesn't have big O, so it is not being deleted like this. So let's try that out. Let's go back to our studio, SQLite Studio. Okay, now quite differently, we can always open up another SQL editor and perform a one-liner change. Okay, so let's do that. So if I need to rebuild the table, this SQL editor one is where I come back to. Now you can always select the entire, Control A and select the entire thing and paste it in Notepad to keep or preserve this sequence. And later on, it becomes useful because here is usually where I use SQLite Studio to try out some complicated SQL statements. And if I make a mistake, I get help from SQLite Studio about what is the error, what might potentially be a cure or a problem, and so on. And then once I'm satisfied, I copy and paste it into my Python program. Okay, so I find this SQL editor my best tool in terms of linking me up towards my final goal of using Python to run the SQL command. Okay, quick check at my data here. Do a refresh correctly. These are correct. we'll have to rerun the data again to make sure we don't run the update so that Bill will still have, so we don't run the update here. Okay, so you see that I inserted a single quotation mark, which is basically to ensure that we will have a comment. Okay. Like this, or we can also delete it. Perhaps just okay. All right, now we have this, and what we can do is we will run it again. Oh, we can actually drop the whole table. I do a right click. No, I might as well just do it programmatically. Drop table, customer. Okay, and we run it. Can you see that? Okay, the whole table is gone. Fortunately, we can rebuild the table here and just run it. And again, this has been created. So it's nice to be able to programmatically recreate the table. Imagine the drop was due to a corruption in the database, or a missing file, or a file that you don't know where you store, cannot find it. So you can recreate the database by just running all the sequence of inserts again. Okay, so now instead of dropping, we're going to delete. So I'm just going to copy and paste. So delete from customer where address contains like, contains a capital O. So the word is, the command is like. Address looks like this fuzzy form, right? So %O%. First, let's look at our customer table. The data is like this, 4 rows, because we added Peter. So it's slightly different from our slides, but that's fine. So when we run it, rows affected too, because Kate and Bill were dropped. They contain O in the addresses, and Mary and Peter should retain, all right, in the database. Yep, and that's all we got. How do we delete Peter? How do we delete Peter? Well, we can delete from Peter, delete from customer, where name equals to Peter. Yeah. We could have said, if we're not sure, we could say Pete and %, because we weren't sure whether it's Pete or Peter. But there's always a danger, because someone of the name Pete Allison, for example, might just accidentally get deleted when the person you want to delete was actually Peter, right, with the R. So definitely be very sure, be very clear, and try not to use wildcards in deletes. All right, you can use wildcards in search to try to over get what you're trying to get. So if I try to get Peter, you're not sure, you get Pete %, then yeah, you are getting Pete and Peter and Peterson and all the Pete something, and then you're over getting the data, and then you can filter off from there. But you're not deleting or destroying data, so that's okay. But when it comes to delete, yes, you need to be super cautious. So let's try to do this. So the first delete was operating on this. Notice that it yielded nothing. It resulted in nothing being deleted. That's the good thing about specifying the roles that we want to operate on using constraints and relationship. Because if we want to go by search and destroy, so give me the ID 2. If found, then delete. But what if you cannot find ID 2? Then there's a kind of programmatically it's considered an error. Then your program stops, and that's problematic. So what we want is to say delete from customer where any rows having address that looks like having an O, delete. But if not, then forget it. You have done your job, right? So here, when we update, we find that the row having name Peter is gone, and that's correct. Okay, so now that we have this customer table having only Mary information, the information about Mary here, what happens if we do delete from customer? Okay, now we can do that, but what's wrong with this line here? Why is the red squiggly, line being drawn over here? That means we have some syntax error. We're not following SQL's proper statement construction. And if you look around, it's really hard to see where the problem is because everything looks okay and previously it was okay. Why is it that when we type this, it's not? Can we just insert a semicolon? Oh no, what we are missing is the semicolon there. So as the last statement, the last semicolon is optional because it's not really connecting to another statement, right? Um, but if it's in the middle, then it's a must, right? So when we put this in, then we are able to continue. And if we should run it, we are basically back to nothingness. So if we refresh, we do have the table container, but the content is nothing. So that is the effect of delete. Be very, very careful of this kind of statement. Try to triple check before you do anything about delete.